All right, so I wanted to look at a few different probability and odds problems. First, let's look at a deck of cards. So if you're not comfortable, if you're not a card player, you might want to familiarize yourself with a deck of cards. So a deck of cards has 52 cards. There are 4 suits, which are hearts, diamonds, clubs, and spades. Hearts and diamonds are red cards. Clubs and spades are black cards. So there are 13 cards in each suit, which means there are 26 red cards and 26 black cards. There are also 3 face cards per suit, which would be the Jack, Queen, and King. Okay? So if I said, what is the probability? So we're looking for probability of drawing a heart. Well, there are 13 hearts out of 52 cards. So it'd be 13 out of 52, which can be reduced to 1 over 4. The other way to think of it is 1 out of 4 suits are hearts, so 1 out of 4 cards would be a heart. What about if I said the odds of drawing a club? So there are 13 clubs, so 13 would be the number of times we can be winners, the number of times we can get what we want, as opposed to how many cards are there that aren't what we want. So how many cards are in the deck that aren't clubs? And in this case, there are 39. We just did 52 minus 13. Okay, and that can be reduced as well to 1 in 3. Okay, maybe the probability of drawing a face card. Well, there are 3 face cards per suit. That doesn't even look like face. 3 face cards per suit, and there are 4 suits, means there are 12 face cards out of 52 cards. So that would be a 3 in 13 chance of probability of drawing a face card. So there's lots of different combinations we can do with cards. The other thing I wanted to show you is if you have more than one thing going on. So let's have a look at that. So for example, if we have a deck of cards and a coin, and we want to know the probability of getting hearts and heads. So the long way to do this is we know there's a 1 in 4 chance of getting a heart. We saw that in the last problem. So we have 4 different opportunities. We have hearts, clubs, spades, and diamonds. And for each one, after we pick it, we would either roll a heads or a tails. Heads or tails. Not roll, flip, I guess. So if you look, there are 8 different possible outcomes, but only one of them gives us hearts and heads. So the probability of getting hearts and heads would be 1 out of 8. Now the way we can do that mathematically without having to write, these are what we call probability trees, without having to make our trees, is we say there's a 1 in 4 chance of getting hearts, there is a 1 in 2 chance of getting heads, and we multiply them. So to multiply fractions, we multiply our numerators, and then we multiply our denominators. So 1 times 1 is 1, 4 times 2 is 8. Okay? So the same idea, let's say I have a deck of cards, a coin, and a 3-color spinner. So what that would be you would have something like a circle. It would have like an arrow, like a spinning arrow, and it would be broken up into 3 different colors, and maybe one of them is blue, one of them is green, and one of them is yellow. Okay, so let's say we want to know the probability of, let's say, a 4 of hearts, okay, tails, and blue. So the probability of getting a 4 of hearts, there's only one 4 of hearts in a deck of 52 cards. The probability of getting a tails is 1 in 2. And the probability of getting blue is 1 in 3. So the probability of getting all of those, 1 times 1 times 1 is 1. 52 times 2 times 3 is 312. So the probability is 1 in 312. So that's how we do probability when we have a number of different options.